Our today's class topic is AWS Load Balancer, and we'll cover application and network load balancer both, and we'll show you hands-on demo. So before we start the quick video, just a quick reminder: you haven't subscribed the channel, subscribe the channel, because after complete the 40 days AWS course, I will also create cloud and DevOps related video that will help your career. So don't forget to subscribe the channel. So let's start today's class now. So I put the introduction here. So what is load balancer? Normally when we send traffic to any server, load balancer will distribute the traffic. So if we think we have two servers, then load balancer will send the traffic from one server. Then if another request is come, then it will send that traffic to another server. That will load balancer will load that load distributed to that server. So I put an introduction here. So what happens if your server gets too much traffic? Your app will crash. So that's why we use load balancer. So in this video we'll cover application load balancer and network load balancer. So what is load balancer and what is the advantage of load balancer? A load balancer is distribute traffic across multiple servers. I have already told that. So it ensure high availability. So when our load is distributed to different servers, so our server will work smoothly. That's why it's highly available. So our server will never crash, and that way user get the service all time. And fault tolerance and scalability. So scalability is like when our usage is going high, AWS will automatically scale our server. So load balancer make sure like which server is scaled, that will include it in load balancer. That way the system will work properly. So like if we have two server, and AWS will increase 2 to 4 server, and that extra 2 server will automatically add it in the load balancer. So when the user next user send traffic to load balancer, that load balancer will send that traffic to the new server. That way scalability happen. So without load balancer, scalability is not possible. So there is normally 4 type load balancer in AWS available, and most the common one is application load balancer and network load balancer. So application load balancer will shortly is called ALB. So it's working in layer 7, and it will cover HTTP and HTTPS protocol. So that is one advanced feature is available in ALB, which is smart routing, and will show you the hands-on demo path-based routing. So like if you send any traffic there /app or /error, that will show you different messages from a different server, or we can also show you different messages also. And network load balancer is shortly it's called NLB. So it's work with layer 4, so it will cover TCP and UDP protocol. So it's ultra high performance. So if you need any performance like more, then we'll use NLB, but it has no option for advanced routing option. So like if we do these things, that is not available in network load balancer. It's a simple one, but it's highly performance. So in architecture, like user will send data to load balancer, and then load balancer will send traffic to EC2 instance. So if you have multiple EC2 instances, load balancer will distribute those data from those EC2s. And don't worry, when you'll see the hands-on demo, you will see it's very easy to create a load balancer. And now we'll what step we've covered in the demo, I put it here. So first we will launch 2 EC2. So one is web server 1 and one web server 2. Then we'll install Nginx in both servers. Then we'll put a customized page to make sure which server showing which page. Then we'll browse that specific server. Server 1 will see so server 1 message, and server 2 is showing server 2 message. Then we'll create a application load balancer, and for creating application load balancer, we need to go to the EC2 dashboard, create load balancer. Then we'll select the application load balancer and give a name, and we'll select internet facing, and we'll listen at port HTTP 80 port, and select subnets. We need to select at least 2 availability zones. So depends on your AWS region. At least you need to select 2 availability zones. So most of the availability zones have at least 3 availability zones. So create target group. We need to create a target group, and those EC2 will include in that target group. So when load balancer send traffic to EC2 before it's sent to the target group, so under target group which EC2 is available, that EC2 will get that data from that load balancer. So for creating target group, we need to make sure its instance type will protocol HTTP, and we will set the port HTTP, and both EC2 we need to add it that target group. Then create application load balancer. Then we'll test After creating the application load balancer, we will get a DNS name. If you browse that one, you can see like a page is showing from server 1, and again if we refresh that link, we can see we can get the page from server 2. So we can see traffic is distributed. So advanced feature of ALB or application load balancer, we have already told that we have a application load balancer have a path based routing. So like if we add any path like devopssteps.com/eo, then we can show a specific message. Those steps I put it here. So when you see the demo, you can see that's very easy. This test is a little bit like confusing, but I will see when you see the hands-on demo, you can see everything is easy. So hands-on create NLB, same way we can create application load balancer. Just make sure you need to select network load balancer, then you can put the protocol because it's layer 4, so we need to work with TCP or UDP, and then we'll select port. It is same way we need to create a target group, and we need to create the target group again, because like application load balancer target group and network load balancer are different. So in network load balancer, we need to again create another target group for working with network load balancer. Then we'll add those same EC2 in the network load balancer. Then you can see the DNS. You can see everything working fine. So difference between application load balancer and network load balancer is like application load balancer, network load balancer layer, it will work in layer 7. Application load working with layer 7, and NLB working layer 4. So protocol ALB is working with HTTP and HTTPS, and NLB is working with TCP and UDP. Routing option, ALB has smart routing option, and NLB is simple, it has no smart routing option. And speed is ALB is medium, and NLB is very fast. So real DevOps use case in application or network load balancer is when you're using microservice routing, we are using ALB, and for high performance apps we are using NLB. So when we need the performance more crucial, then we will using NLB, and NLB will distribute the traffic very fast, but it has no advanced feature. And we also use Kubernetes option, we are using ALB. So common mistakes are happening when you are doing application load balancer work. So like when load balancer, how can find out this server is alive, if this server is okay or not? That way it will send the traffic to any specific location. By default it will send that IP or root level, also some developer are preferred to use any specific file like your domain /healthcheck.html or PHP. So if that page is getting then load balancer think this server is alive. If this page is not coming, then load balancer will think this server is down. That way it makes sure it's health check. And one of the problem is if we put the health check /health.html and that file is not available, then health check will not occurring. So our load balancer will show the server is down. So this is the common mistakes developer doing. And another is security group. So when you're creating security group, we need to make sure data is allowed from that user to that port or that any specific subnet. So make sure security group are allowed all port like HTTP or HTTPS. So or any traffic come from any security group or any different issue. We make sure all these things are allowed. And sometimes we are doing wrong port, like we are try to enable HTTPS, so which is working 443, but we are allowing 80 port. So that way also it will not up. So these common mistakes are happening when developer working. So summarize today's class is ALB is a smart routing option, and it's working HTTP and HTTPS both, and NLB is high performance and using TCP protocol. So here today's homework is we'll create two EC2, then install Nginx in both EC2, then create application load balancer and create also target group, and those target group add in your two EC2. Then you can check the DNS of your load balancer and make sure the page is coming from both server. So now let's go to the AWS console to demonstrate the to this class. So we are in EC2 console. You can see there is no server is running. First we need to create two EC2. Give a name like I put A1, like keep saying Amazon Linux iOS we need to make sure this is simple website, so we need to try to reduce our price. So T2 micro, and to select a key pair, so log into the server. So just for simple, we are selecting existing security group and go to the advanced section. So we need to run some script which we refer to after run the server by logging that command. So that, like, if we run this command here, that will run the command when server is ready. So for that you need to run in bash, then sudo yum update -y. Make sure you put the -y. Then we need to add those two commands to run the nginx. So first one is install nginx, and need to restart the nginx. Then we'll create that file. So go to the documentation, just copy that one. That will add same hello server one in both file, both server. So we need to log into the server 2 and change the message also. So now go to the create 2 and launch an instance. So it will create 2 server at a time with install nginx and the default script. So let me check. So let me disable the filter one. So you can see this pending is running. So here is A1 and A2, make it A2. So browse it. So it will not come, it will take around 30 seconds. Another one is A1. Okay, it will take some time. So now I need to go to the A2 and edit that message. So go to the IP, now go to the control, and so SSH -I, we're using that one, EC2-user. Get inside the server. Then we need to just same line, I just need to make sure it is showing 2. So copy that one. So now server 2 will show server 2 message. So now if you browse that one, you can see this one showing server 2, and if you refresh that one, is already showing server 1. So that way you can identify data is serving from which server. So server 1 is server showing server 1, and server 2 is from another server serving server 2. So now we'll create the application load balancer. So in the same way, I see to dashboard, you can see the load balancer. Just open that in a new one. So create load balancer. So you can see the 4 load balancers available. So classic load balancer is the most old of AWS one, oldest load balancer. It has not that advanced feature. It has just like traffic that to any specific server. It has no advanced routing, and it is the oldest one, and it's very simple, but its pricing is very low. So this another one is application load balancer. You can see this is HTTP, HTTP is both are working, and network load balancer is TCP, UDP, and TLS both are working, and another one is gateway load balancer. This is a most expensive one. So we are creating ALB or application load balancer. For that we need to create application load balancer. We can give a name. So ALB1. There is 2 options: internet facing and internal. So if you want to don't do anyone access to our server, so if it's in private mode, then we are using internal. Some application we need like internal mode, like when you are using server like our database. If you have 2 database, then we try to send traffic from one server then another server, and normally we know database is not good idea to access from internet. So that way we are using internal facing. So which one we don't want to access publicly, then we are using internal. So in my case we are using internet facing, and we're choosing IPv4 network mapping. Keep it same. Make sure you choose at least 2 availability zone or subnet. Then a security group. For better, we need to create a security group to work properly. So ALB 25, we need to copy both. For inbound rule, you need to add HTTP and any other traffic, or you add another one or make sure everything is working fine. So after that we can delete the all traffic. We need to keep only HTTP one. So make sure you add the inbound rules only. So create security group. So now go to the load balancer, click that one, refresh that one, select your one, which is, I think this one, ALB 25 April. Okay. Oh, now listener, keep it same HTTP and HTTP port. We are not using HTTPS, so we are using HTTP, so we need to select HTTP. So in target group, we need to create a target group to add those EC2. So you need to click that one for creating the target group. For same way, here is 4 options: instance, IP address, or load balancer function, and application load balancer function. So if you're using instance, and in this video you're using instance, that will support ALB, NLB, and GWLB. Both 3 are working with instance. So IP address same way, it will accept 3. And if you're using load balancer, so lambda function, then we can only use ALB, and application load balancer we can also able to use NLB. So subnet group also you can use instance, IP address, or lambda function, or including load balancer. So like if you have a load balancer, then under that load balancer you have a target group, and under target group you can also add load balancer. So in my case we are using instance. You can give a name TZ1, then ALB1, protocol HTTP and it is fine, IP address fine, keep everything same. And health check, you can see we are using no additional page health.html or something, so we just use the same IP, so we don't want anything. So if you click advanced health check, there is some option. So here is one health threshold. What is it? The number of consecutive health checks success required before considering an unhealthy target healthy. So it will send traffic to any server 5 times. If 5 times it get the page, then it will declare it's a healthy server. So if it's healthy server, then load balancer will send traffic to that server. Otherwise, if it's unhealthy, then it will not send traffic to that server. That way we can like make each server is healthy or not. You can change. If you normally you need to change 2 to 10, so default it is send 5. So unhealthy threshold, the number of consecutive health checks failure required before considering a target unhealthy. So if we get any server, we send any request to any server, if we found this server is not getting the response, then it will declare it's unhealthy. So like load balancer will send any request to that servers, is the server is alive for browsing that website. So if it don't get any response 2 times, then it will declare it is unhealthy. Then load balancer will don't send traffic to that server. And timeout, the amount of time in seconds during which no response means a failure health check. So when load balancer send traffic to that server, and if 5 seconds it will not respond any traffic or any response, then it will declare as it's unhealthy. So you can edit the time also. Interval, like the approximate amount of time between health checks of an individual target. So we can send 5 requests to any server. So what is the interval time? So here I put 30 seconds. So every 30 seconds it will send another. So let's send traffic 1, server is healthy or not. Then after 30 seconds you send another. So this is the time limit. So you can edit this one from up or down arrow. We can also select and we can edit that our target one. And if we get 200 success code, then it will declare is healthy and we get the server is alive. So this is advanced level section, and keep everything same for your first time. And now need to click next. So you can see this to EC2 is available here. Just select that to EC2 and click inbound as pending. then it will add those EC2 in your target group. Click next and create target group. So it will take around 30 to 40 seconds to make it healthy. So you can see we select 30 seconds to make any request to server. Then after 30 seconds you send another request. So if you get 5 consecutive requests is healthy, then it will declare it's a healthy server. So initially it will 2 servers available. You can see there is no healthy, and then there is no healthy, and it's 2 is unused because it's in 30 seconds. So after 30 seconds it will show in queue, in use, then it will get that server, then it will declare it's healthy. So it will take around 40 seconds to 1 minute. So let me pause the video, and when it will become healthy, then we can browse that server. So wait 30 seconds. Let me pause the video. So we need to go to the load balancer, just add those things. So target group, in the meantime it will showing the healthy. So we're using adding it in target group. So if you refresh that one, you can see our created one. So TZ one, this one. So select that one. Then create load balancer. So after creating the load balancer, you can see is showing provision. It will take some time to active. So you can get the DNS name which one need to browse. So click that one. So same, it will take some time. So load balancer, need to refresh it. It will show it's active and target group. So you can see it's now initiating. So it's showing it's healthy when it's requesting getting from the load balancer. So same way it will take a little bit time. So let me pause the video again. So after around 30 seconds you can see now it's showing active, and if you go to target group, let me refresh that one. You can see now it's showing 2 healthy, and this server is also showing healthy. Now if you browse this page, you can get the website. So now this page is showing from server 1. If you refresh that one, it's showing the server 2. So sometimes it's sending data to server 1 and sending to server 2. So that way our users will be distributed, and we get the website smoothly. So user don't get any downtime or anything. So smoothly we can access the service. So now go to the documentation. So now we can see, we can ALB, we can show one thing. So this one. So the advanced routing, there is path based routing. So if you access this DNS, then slash something, you can get something message. So this is path based routing. So for getting this, this is our load balancer. So you need to click that load balancer, then you can see the listener port HTTP it add listener. So you need to click that one. So when you're using HTTPS, you can add listener, then you need to add HTTPS. So in my case we are using HTTP 480, so click that one. Then you need to click add rule. Now you can add anything. So for name tag, you can give any tag to rule 1. Then you need to type add condition. So there is some option path based query string, HTTP request method, HTTP header, source IP. So we are using path based. So we are trying to error, then we get a message. So if our IP or DNS name /error, then we get something. So what you want to get, we can configure that one. So /error, then go to scroll down. So then we can send this traffic to any target group. Then you can also send that /URL to any specific URL, or we can also get any fixed response. So in my case we are using fixed response, and select 404 response code, and there is content tab. You can use anything. So simple one is text pane. We can just give any message, the page is not found. So then click next. You need to give a priority, so let me put 5, then next, then add rule. So you can see the priority. So if we add another rule, if that one is 10, then it will go to the bottom, then 5 will work first, then it will go 10. So that way give priority. So which one is lower one, that will work first. So now if we get that URL like our DNS/error, then we get the message the page not found. So this is our DNS. So error, you can see the message the page not found. This is the like advantage of ALB. So we can do lots of condition add in our load balancer. So now go to the listener. So same way we can add a network load balancer also. So for network load balancer is same thing. Just create a load balancer, then you can do sorry, this one is gateway load balancer. So network load balancer, you need to click that one. Same way you can give a name. You need to put internet facing. Then you can select two availability zone, security group. Everything is same. Just go as like we did the ALB. So TCP put same. So if you type next, then you can get the target group option. Then you need to add the target group. So here is the target group. So you need to also create the target group and make sure ALB one target group and NLB network load balancer target group is different. So you are not get the target group here. So you need to create the target group again. Then you need to add the EC2 as same like. So it's the same thing. So let me show. So NLB1. So keep it facing same thing. So I'll select at least two availability zone. Then target group, we need to create the target group. It will work same way. But NLB TZ1, same way, health check, next, add the EC2, create target group, go to the network, NLB, refresh that one, select your target group and create load balancer. So same way, it will take some time and it will get active. Then you can get this DNS and browse and you can get the page. Okay, same way. Okay, so the same way, it will take some time. It will show healthy and it will show healthy. Then you can get that page from that URL. This is the NLB, and NLB is NLB something. Okay, so now after complete the testing, you need to make sure you delete everything. For first deleting, you need to select the EC2. So our EC2 is these two, so A1 and A2. Terminate data. Then you need to go to the load balancer, select both load balancer and active, delete load balancer, confirm. Then target group, if it's fine, target group is not getting any charge. So TZ1, TZ, that one, these two, action, delete. So it's going to delete. So that's all for today's class. So if you found this video is helpful, don't forget to like, share and subscribe this channel. In the next video, we'll cover in different topics, which is I think S3. Let me go to the documentation. Yes, our next class will be S3 deep drive. So we'll see everything in the class like S3 related issue. So after that class, best of luck. Bye.